In this presentation, we will learn how to use variables in an Arduino program. Following are the objectives of this presentation. To show that computations can be conveniently made in Arduino. To learn how to define and to learn how to use following types of variables in an Arduino program. Integer type of variables and floating point type of variables. Other type of variables we shall be discussing in later presentations. In order to achieve the learning objectives as mentioned earlier, a problem is framed. A problem statement describes the problem to be solved. Use an integer variable that designates a digital pin. Use integer variables that contain the time period, on time, and off time in milliseconds of a pulse train with adjustable floating point duty cycle. This pulse train is to be produced on pin 13 so that it becomes visible on LED. Use a floating point variable that contains duty cycle of the pulse train to be produced. Carry out computations to get values of on time and off time for the specified time period of 2 seconds and duty cycle of 0.5. Let us put down the steps to be followed for achieving the desired task. Step 1. Define an integer variable named pin 13 to represent pin number 13. Step 2. Define an integer variable named onTime to represent the on time of pulse train in milliseconds. Step 3. Define an integer variable named offTime that represents the off time of the pulse train in milliseconds. Step 4. Define an integer variable named time period that represents the time period of pulse train in milliseconds. Step 5. Define a floating point variable named duty cycle that represents the duty cycle of the desired pulse train. Step 6. Define pin number 13 of Arduino Uno board as output pin in void setup function. Specify or assign time period of the pulse train in void loop function. Step 8. Specify or assign the duty cycle of pulse train. Step 9. Compute the integer on time. Step 10. Compute the integer variable of time. Step 11. Write logic high on pin 13. Step 12. Generate a delay of time equal to on time milliseconds. Step 13. Write logic low on pin 13. Step 14. Generate a time delay of time equal to of time milliseconds. In order to repeat the on and off pattern of pulses, go to step 7. Let us convert these above mentioned steps into an Arduino code. In first section, we will define variables. The same thing has been displayed here by putting two backslashes, that is comments, and in the comment we are writing defining variables. int pin 13 equal to 13 semicolon. Pin number 13 is defined as an integer variable to designate pin number 13. Int on time semicolon. On time is defined as an integer variable. This represents on time of the pulse train. Int of time semicolon. Of time is defined as an integer variable. This represents off time of the pulse train. Int time period semicolon. Time period is defined as an integer variable to represent time period of the pulse train. Float duty cycle semicolon. Duty cycle is defined as a floating point variable to represent duty cycle of the pulse train. With this, all the variables used in the code have been defined. In the next step, we will define the variable pin 13 as an output pin in function void setup. Type void setup, open small bracket and close small bracket. In the next line, type open curly brace, go to the next line, give a tab space, type pin mode, open small bracket, pin 13, comma, output, close the small bracket and put semicolon. Next line, put the closed curly brace. Notice variable pin 13 is used in place of pin number 13. This completes the function void setup. In the next step, the main function void loop is written. Type void loop, open small bracket and put close small bracket. Go to the next line and type open curly brace. Go to the next line and type time period equal to 2000 semicolon. This defines the value of time period integer variable equal to 2000, and this statement corresponds to step 7. In the next line with the same tab space, type duty cycle equal to 0.5. This statement corresponds to assignment of value 0.5 to a floating point variable duty cycle. This corresponds to step 8 as mentioned earlier. In the next line with the same tab space, type on time equal to duty cycle multiplied by time period semicolon. Here, by multiplying duty cycle with time period, the resulting value is assigned to on time. This corresponds to step 9 as mentioned earlier. Here we are capable of showing that my microcontroller can make complex computations. In the next line, again with the same tab space, type of time equal to time period multiplied by inside the bracket 1.0 minus duty cycle semicolon. Here, by multiplying time period with 1 minus duty cycle, and the resulting value is then assigned to an integer variable of time. This corresponds to step 10 as mentioned earlier. In the next line, with the same tab space, type digital write, open the small bracket, pin 13, comma, high, close the small bracket and put semicolon. This statement when executed writes logic 1 on pin 13, that is voltage at pin 13 will become 5 volts. This corresponds to step 11 as mentioned earlier. In the next line and with the same tab space, type delay, open the small bracket, on time, close the small bracket and put semicolon. Execution of this statement will result in a time delay of the duration equal to integer variable on time milliseconds. This corresponds to step 12 as mentioned earlier. In the next line, again with the same tab space, type digital write, open the small bracket, pin 13, comma, low, close the small bracket and put the semicolon. This statement when executed makes pin 13 to take low potential, that is logic 0. This corresponds to step 13 as mentioned earlier. In the next line and same tab space, type delay, open the small bracket, of time, close the small bracket, put semicolon. When this statement gets executed, it generates a time delay of integer value of time milliseconds. This corresponds to step 14 as mentioned earlier. And now finally the loop has to be closed. For achieving this, we will put a curly brace which is closing one exactly in the same column in which the opening curly brace was placed. Here the code is visible on the computer screen, and after compilation and uploading, the execution of this program on Arduino Uno board is here. I have set the duty cycle equal to 0.2 here, and the time period is set to 2000.